Now let's take a look at how we can get between mass of an atom and the amount of it, aka why we're doing all this learning what the mole is. So 1 mole of atoms of any element has a specific mass, and we call that its molar mass. And it's measured in this unit called grams per mole. So as you might imagine, that means we're going to have some relationship between how many grams does something weigh for every mole of it that we have. An element's molar mass is equal to the element's atomic mass in atomic mass units, AMUs. This number is the one we find under the periodic table when we look at it. So for example, when we looked up hydrogen, and it had a 1.008 there, that had two meanings. Hydrogen on its own has a mass of 1.008 AMUs for one atom on average, and 1.008 grams of hydrogen is equal to 1 mole of hydrogen, because that has a mass of 1.008 grams per mole. So in this way, it's easy to point out that we developed AMU very specifically to be related to this. That way it makes a nice easy conversion. So all the numbers you see on there on the periodic table, in addition to being the mass of a single atom, it's also the mass in grams of a mole of that atom. So let's take a second example. If you look up the mass of aluminum on the periodic table, it has the number 26.98 written under it, which means one atom weighs 26.98 AMUs. That means it has a molar mass of 26.98 grams per mole. So that gives us our conversion factor. 26.98 grams of aluminum is equal to 1 mole of aluminum. Other atoms have different molar masses. So a third example, 12.01 grams of carbon has a mass of 1 mole of carbon. This also means that it's going to depend on what element you have for how much it takes to reach a mole. So it takes 26.98 grams of aluminum to have a mole of it, but it only takes 12.01 grams of carbon to reach that mole. So I'm going to have to weigh out more aluminum if I want a mole of atoms of aluminum. And then if I want an element that's really light, a mole of hydrogen is 12 times lighter than my mole of carbon. So it takes a lot less hydrogen in terms of mass to get to the mole. So let's now use this in a worked example. So how can we do something useful with it? So let's say we want to know how many aluminum atoms there are in a piece of aluminum foil that we weighed on a scale and weighed 3.65 grams. The molar mass of aluminum is 26.98 grams per mole. We can get that from the periodic table, or we also listed it on the last slide. So let's take a look at this. So we have 3.65 grams of aluminum. I'm actually going to do this in 2 parts, and then I'll show you how to do it as a 1 step. So 3.65 grams. We know that for every 26.98 grams of aluminum, there's 1 mole of aluminum. Therefore, if we just do this 1-step calculation, we can get the moles. So you have 3.65 divided by 26.98. So that would give us that you have 0.135 moles of aluminum. This isn't finished with the problem yet, but I want to mention that this calculation right here, where you go from grams to moles, is probably the most important calculation you'll do in this chapter. You are going to do this conversion in every chapter multiple times, many times on multiple problems for the rest of the semester. This is because you almost always will find out about your substance through mass. It won't be the only way we do it, but it's a really common way because masses are easy to measure. That's how we know how much stuff we have. We put it on a scale and we say this is how much it weighs. The molar mass is very easy to get because it is on your periodic table. So it makes for a really good conversion to get from I weighed this, how much of it do I have? And we want to know that because how much you have tells you how it's going to behave in a chemical equation. So once we start getting to balancing chemical equations and working with them, it's all about how many atoms do you need to do this chemical reaction, not how much do they weigh. So weighing is the thing we can easily do. The number of atoms there is the thing we need to know so we can use our balanced chemical equations. That's why you're going to do this calculation a whole lot. And if you get nothing out of the rest of this chapter, please work on this and make sure you can go from grams to moles and moles to grams. So after that little aside, let's finish the problem. So the problem asked me for atoms, not just in moles. So we'll go 0.135 moles of aluminum. For every mole of aluminum, you have 6.022 times 10 to the 23 atoms of aluminum. So my moles cancel, and I've just left my number in my calculator, so I'm going to multiply it by 6.022 times 10 to the 23rd. Oh, but there we go, times 10. Let's see, I did something somewhere. Oh yeah, I just didn't. There we go. It's okay. So for this, I see what happened. I multiplied it by 6.022 times 10 to the third, so I was confused why my answer looked really small. So that is why. Now I'm fixing it. There we go. So you would get that you have we've got 3 sig figs, so 8.14 times 10 to the 22nd atoms of aluminum. So that's how many atoms of aluminum we had. In the majority of problems in this class, you'd be able to stop at the mole step, but I want to make sure you know how to go to the step after this. And this is because we really want you to get conceptually the idea that this 3.65 grams of aluminum foil, which isn't all that much, may have a really small number of moles, but that represents an absolutely gigantic number of atoms compared to what we're used to thinking about, at least. So now, let's have you try one. So let's just work with moles this time. Don't worry about going all the way to atoms. So how many moles of gold would be necessary if I wanted to have 10 grams of gold? Give that a try. And if you're having trouble with it, molar mass of gold is 196.97 grams per mole. In the long run, though, you're going to need to get used to looking that up on the periodic table. So try to have access one when you're trying to do your homework, and definitely use the one on the quiz that's up above. I put it at the top of the quiz. It will be helpful for you. So hopefully you have an answer now. Let's give it a try. So 10.0 grams of gold. We know the molar mass means that for every 196.97 grams of gold, we'll have 1 mole of gold. And we do that, and we will get 0.0508 moles of gold. Yeah, it's gold. Nope, I had 3 significant figures. I made sure my answer had 3 significant figures in it as well. Now, talking about molar mass, there's one more thing we can do with it. We want to talk about how to identify an atom based on its molar mass. So it's possible to figure out both the mass and number of atoms for a sample to calculate its grams per mole amount, to figure out what its molar mass is. For right now, we're just going to tell you that's possible. We will, as time goes on, look at some examples of ways we might find out how many moles of something we have without knowing its identity yet. So just take it for granted now. We're promising you there is a way to do this, so it's not just some calculation we're doing because we want to make you try to solve problems in different ways. This is something scientists can do and chemists can do, and we will look at it in later sections in the future. So let's take an example right now where we're just given some numbers. So if I had 24.02 grams of a substance and 2 moles of it, what atom could it be if I was told it definitely had to be an atom? Well, we know that molar mass is going to be equal to the mass, because that's in grams, over the number of moles, in moles. So we have 24.02 grams divided by 2 moles. They're already in good units. And if we do that, we're going to get 12.01 grams per mole. And if we look on our periodic table, we will find that this is the closest molar mass to carbon, which has a molar mass of 12.01 grams per mole. So for a second example, let's say you had 48 grams of a substance instead, but you also had 3 moles of it, not 2. I want to know which of these 4 atoms could it be. So give it a try. Okay, so now that you've done that, we're going to look at the same setup, mass in grams over moles. And we had our 48.00 divided by our 3.00 with this in grams, this in moles. And when we do that, we're going to calculate that it's 16.0 grams per mole, which we can quickly identify here. That is the atom oxygen. So in this way, we can use the ideas of grams and moles to figure out what element is we are looking at as well, even if I don't initially know its identity. So we can use other techniques to find out this information, help us figure out what element might we have present in our sample.